9.3 is about slant asymptotes. So far we have learned about vertical and horizontal. And how do we find a vertical asymptote or totes? Set the denominator equal to 0. A horizontal asymptote, we use the phrase Bobo Botten eats DC. And what is the circumstance in which we don't have a horizontal asymptote, when there is none?
When it's bigger on top.
When it's bigger on top. So if we have bigger on top, we have none. So Botten, we have this none. And therefore, we don't have a horizontal asymptote, but we do have this thing called a slant asymptote. And a slant asymptote, the degree of it, I'm going to say degree equals, well, I don't really like how that's phrased. I'm going to try and put this in my own words. So when you have exactly one more than the denominator, you have one slant asymptote. If you have an x cubed over just an x, then you would have two slant asymptotes. So it's like the degree of the top minus the degree of the bottom is the degree of your slant asymptote. Typically what we will see is where you have one higher degree on the top than the bottom. So that means that your slant asymptote is a line, like an mx plus b line. If it were x squared or x cubed over x, like you had a degree of 2, then it would make a parabola slant asymptote. But we won't really see too many of those. So you can have either or. You can either have a horizontal asymptote or you can have a slant, but not both. So it only occurs when it's bigger on top. So to find a slant asymptote, we will use long division or synthetic. And ignore the remainder. We don't do anything with it. It means nothing to us. So let's look at our example. And we'll do slant asymptote last, okay? So first thing we want to do is factor. Can I factor the top? What would that be? You've got the number first, so that means your x won't go first, but your numbers will go first. Because you have a negative x, and you don't want to deal with that. No, don't do that.
Is it it's 4 minus x and 1? I don't know. This is weird.
It is weird, but we treat it like it were the x. I mean, instead of the x being first like we're used to, we'll just put the number first and the x last. So we know that x and x will go at the end, right?
Oh.
And one will be a plus and one will be a minus. There will be different signs because the last number is negative.
It's got to be a negative 4. So I think it's going to be 1 plus x and then 4 minus x.
Well, what are multiples of 4? 4 and 1 or 2 and 2?
4 and 1.
We can try 4 and 1. So let's put the 4 first.
Positive 4, negative 1.
Well, we want to make a positive 4.
Negative 4.
Okay. I thought
Yes,
said we had
that's
to make a
right.
negative.
Does that work?
Yes.
Because it becomes 4 minus 4x plus 1x. So that becomes a negative 3x minus x squared.
I think we need to switch the 4 and the 1. I thought we were trying to make a negative 4, but
No, because look, if I take the outside and the inside, I have negative 4x plus x, which equals negative 3. So this is good. This is good. Okay, and then can I do anything to the bottom? No. Can anything cancel? No.
No.
So I have no holes. Vertical asymptote.
It's 2.
X equals 2.
X equals everyone. Horizontal.
Horizontal. It's bigger on top. So,
Is it bigger on top since we just have 2 X's?
let's go ahead and do X and Y intercept, and I'll show you how to do slant asymptote last, okay?
Okay.
So X intercept means I'm doing what? Okay, so I've got 2 of them. -4, comma 0. 1, comma 0.
Wait, how is it 1?
Because you subtract the 1.
So I set both of them equal to 0. So 4 plus X equals 0. 1 minus X equals 0.
Oh, is it because like you're just dividing negative 1?
Mhm.
Okay.
And then y-intercept, I'm plugging in 0 for all of the x's. So 0, 4 plus 0 times 1 minus 0 over 0 minus 2.
Just be
Negative
-2.
1.
4 over negative 2, which is
-2.
2. So 0, comma, negative 2. Now let's go ahead and plot those.
Thank
Bless
you,
you.
guys. One more coming up. Wait.
So point, 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 and my vertical asymptote at 2. Okay, now the last thing we want to do is our slant asymptote. And comparing degrees of top and bottom. The top is what? Bigger, but what is the degree? 2. What's the degree on bottom? 1. So I can use synthetic division on it. If it's only 1 bigger on top, I can do synthetic division. If it's 2 bigger on top, I have to do long division, okay? So with synthetic division, I'm going to take my coefficients, which are the numbers that are in front of the x squared, the x, and the number. So what are those coefficients? The x squared one goes first.
1.
Negative 1. The number in front of the x,
-3.
and just the number 4.
Why do we do negative 1?
Wait, where do you?
Because it's negative x squared. Because it's if I rearranged this, it would be negative x squared minus 3x plus 4, right?
Yes.
And so I'm taking the coefficients that are in front of each term. So there's a negative 1 in front of the x squared.
So we do want to rearrange it for this part.
For this part, yes.
Okay.
And then what number goes in that box? What am I dividing it by? 2. So it's like I'm setting this equal to 0, which we've already done. So steps of synthetic division, what do I do first?
Hold on.
Just drop the 1.
Drop the negative 1 down, and then I multiply it. And then I add down, so negative 5, multiply, and I get negative 6, but I ignore it. You can put a big X through the negative 6. I don't need the remainder at all. It is irrelevant to me. And what is my new equation? This is a line, so y equals negative x minus 5. Good. So my slant asymptote is y equals negative x minus 5. Now, if I were to graph that, I would put my y-intercept at negative 5. And it makes a slant asymptote, just like this.
Is it a parabola in the middle?
So in the middle, it's going to be tracing my asymptotes. It's going to look like this. Now I know that it's not going to be on either side because, like, it can be over here because it doesn't cross the x-axis. So there's nothing over there. And there's nothing over here because it doesn't cross the x-axis again.
Couldn't it be just like, you know how we have the,
Like this. But the thing is, if it were tracing the asymptotes, it would have to go through the x-axis.
okay.
Same here. Because lines will always trace the asymptotes. If they did so on either side, they would have to cross the x-axis. Can you factor the top?
Nope.
No. So just leave it.
No,
So, for x-intercept, you're setting it equal to 0. Move the 2 over. Divide by 3. Are we good to that point?
Of course.
When you cube root it, I don't know what that is. Why is it not imaginary? Because you can. When you cube root something, or even if you had something to the third power, it can be negative because a negative times a negative times a negative is still negative. You're doing that 3 times.
I'm not like you said. Never mind.
So you can't square root a negative number because that would be imaginary. But you can cube root a negative number.
Why did you pull out a negative?
You don't have to. I just did. I like it on the outside.
So how do you know where to plot that point?
So it's a number, it's a very small decimal. So it's going to be between 0 and -1. And it does not matter really where you put it. But it's like taking the square root of 2 and the square root of 3. The square root of 2 is like 1.414 or something. The square root of 3 is something a little bigger than that. Okay, for slant asymptote. So when you have I don't know why she did long division here. So when you have a parabola on the bottom and it's not just an x, you have to use long division. So if it's like x squared, even though it is 1 degree bigger, I can't do synthetic division on an x squared. Okay? So I would need to do long division in this case.
She said everyone freaks out like someone died.
So let's set up our long division scenario, okay? It's not bad, I promise. And we don't have to use the remainder, so that makes life better. So I have x squared minus x minus 6 right here. Then I put my numerator on the inside, and I put a 0 where the other things, like I don't want to skip any terms, right? So I've got 3x cubed plus 0x squared plus 2.
What 2 in this?
Okay. Do what? So from here, long division, I think, how do I get from here, this should be cubed, sorry. From here, so from x squared to 3x cubed. What do I, 3x, good. So then I multiply everything, so 3x cubed minus 3x squared minus 18x. And then I flip every single sign. Minus, plus, plus.
Can you apply it to like all of them?
You change the sign for all 3 of them. Like, so my black ones are the... So then this cancels, and I'm left with 3x squared plus 18x plus 2. Now I do the same thing. How do I get from x squared to 3x squared? 3. So plus 3 goes on top. I guess I should erase this line. 3x squared minus 3x minus 18. Then I change every sign. Minus, plus, plus.
Guys,
Then this becomes the remainder, so I'm done with it. I don't even need to add down or anything. I'm done, because I can't go from x squared to x. I can't go down a degree, right? So I only needed to do it twice.
that sounds great.
So my final answer, my slant asymptote is what?
Y equals 3.
Good. How do I graph that?
Well, you go to your x-intercept of 3.
You go up 3 and up 1.
Good. Up 3 over 1. And I go down 3 over 1.
Wait, how do we get there? There was 0, 0, 0.
Yes. Start at 0, 0. Go up 3 to my y-intercept, and then the slope is 3, so up 3 over 1. So it looks something like this.
Please don't make us do test.
So from here, and I'm going to draw this up to where it meets. When you have, and I'm going to draw this down. When you have these little, like they meet at a diagonal, like this, you have functions that go in between those. So I'm going to have a little guy here and a little guy here. So just know that they go in between them.
So we have to draw this.
And that usually happens when you have 2 vertical asymptotes and a slant.
Even if it's completely off the graph.
And it will probably be off the graph a little bit. And why do I know, or how do I know that it can go in between those? Because it doesn't touch the what? The x-axis. Like it couldn't be here, because then it would have to do what? Cross the x-axis. And it couldn't be here, because it would touch the x-axis. Now, I do have these intercepts. And what did we say about horizontal asymptotes? That things go through. They can be crossed. It's the same with slant. They can be
So
crossed.
it's gonna go like this. So it's gonna have the S.
Yeah, so it's going to go like this.
Yeah. Because I tested point like 1 and it's a negative, so that means it's gonna
Perfect.
Looks great.
You wouldn't necessarily have to test this one, but you could.
Are we done? You're killing me. You're killing me.
No, these are not bad.
You're killing me.
It's just 4 more things.
Yeah, not
I
bad.
didn't do this when we were doing it the first time.
Okay, let's look at, yes. And these are just possible. So it doesn't mean that there isn't one right or wrong answer. There are just specific things I'm looking for. Okay. So what are some things that we see from this graph before we start making anything? We've got a hole at 2. What's the y value? 1. So basically at x equals 2, we've got a hole.
And then
There's an x-intercept at
negative 1.
-1, 0. What about the y-intercept? Could we figure that out?
it looks like
1/3? How did you figure that out? Just eyeballing it?
Yeah.
And the slope is up 1 over 3.
You are a genius, Tony.
So we know that it's going to cancel to be a line.
Yeah.
Right? So we know that we'll have an x minus 2 on top and an x minus 2 on bottom. What else will be on top? X plus 1. How'd you figure that out? The x-intercept.
Yes.
And then I need to add one more thing in there.
Something on the
1/3 for the slope. So 1 on top, 3 on bottom. Or you wouldn't have to necessarily put the 1.
Oh.
And if I were to check this, these cancel, and I'm left
A
with
whole lot.
1/3 times x plus 1.
Wow. That's like
Y'all are awesome.
That's impressive, man.
Okay, let's look at the next one. What are some things we see?
There's a hole at x equals 1.
There's a hole at x equals 1. What's the y value?
Negative.
Good. What else do we see?
There's a horizontal asymptote at y equals 2.
So that means that the degrees have to be the same, right? What about vertical asymptote?
X equals 2.
And any x or y intercepts here?
X intercept at -3.
And then a y intercept.
-3.
Good. Okay, I want y'all to try this one.
I got that.
Okay, so in your steps, I'm going to erase this. And here's the thought process when you're going through this. This is a little tiny eraser. Here's the thought process. First thing I'm going to put is my hole. So I've got x minus 1 on top, x minus 1 on bottom. From there, I'm going to put my vertical asymptote, which means on my denominator, I've got an x minus 2.
Wait, can you repeat that?
So I'm going to put my vertical asymptote on the bottom. So I now have my hole and my vertical asymptote. For my horizontal asymptote, I know that the degrees need to be the same. And then when they cancel, like if I have x squared on top, x squared on bottom, I'm just left with the number. So the number is 2. So that means there's going to be a 2 in the front. So I got that. X-intercept is setting the numerator equal to 0. So that means I need an x plus 3 here. If the numerator is, or if the x-intercept is -3. So I've got that. Y-intercept is just checking. So let's see if I have the right answer. By doing that, I'm going to plug in 0 for x. So 2, 0 minus 1, 0 plus 3, 0 minus 1, or I guess I don't need those because they've already canceled. And then 0 minus 2. So 6 over -2 reduces to -3. So it works out.
Okay, I get all of that except for the horizontal asymptote part.
Horizontal asymptote is, so they both have the same degree, right? If I FOILed this out, I would have x squared over x squared. They would cancel, and I'm left with whatever coefficient is in front. So there has to be a 2 there in order for my horizontal asymptote to be 2.
Okay.
Does that make sense? Okay. All right, let's try the last 2.
They look harder.
I don't think they are.
No.
Well,
Okay, I want you to identify all the things. Do you see any holes?
No.
Nope. So that's going to make life easier.
Can a hole be an imaginary number?
No.
he is always making me bigger on top, but there's no hole.
Okay, there's no hole means
I like
nothing
some-
Bigger on top
cancels.
is for
If I do
horizontal
this one more time,
asymptote.
There is a horizontal asymptote at 4. So that means that they have to be the same degree, and then so they're both x squared, but there's 4 on top.
I was mixing my horizontal asymptote and my holes.
So I did my vertical asymptotes first, my x-intercepts.
I actually got that right.
So BA, x-intercept, this is my horizontal asymptote. And then I checked my y-intercept by plugging in 0. Okay, last one. This is an example where it's bigger on top. Because why?
Because
There's a slant.
Because there's a slant at whatever this line is. What is the slant asymptote?
Well, I need to
Y
pull up sit.
equals
x plus 2. Good.
Yeah.
We have vertical asymptotes where?
-2.
-1
-1 was what I mean.
and
I can't count. What's this?
we have x-intercepts.
It's a 3, not 4.
That's -1
Yeah.
and 3.
And 3, yeah.
-1 and 3. And then we have x-intercepts at where?
1, 0, and 2, 0.
So -2,
What?
0, -2, 0, 0, 0,
Yeah.
and 2, 0.
Wait, what? Where's your negative? Oh.
Right here. 1, 2, 3. Okay, so let's. And do we have any holes? No holes.
No holes.
So isn't our y-intercept just...
We are not porous.
And our y-intercept is also 0, 0.
And the one above... Oh, just kidding.
Okay, so I'm gonna fill in. Do you want me to let you guys try it?
Yeah, we got
Okay,
this.
okay.
Yeah, no.
So on
Oh,
top,
two are
good
zero.
job. On top, I just put my x-intercepts, so 0, -2, 2.
Ladies and gentlemen.
And then on the bottom, I put my vertical asymptotes. To check my slant asymptote, we're gonna check it because we still need more practice, right? So if I were to FOIL these out, because I need to do that for long division.
Oh, I feel so smart.
Why do I need to do long division?
Because you can't do synthetic. Because
Yeah, because on the
Why?
bottom I have an
Why?
x squared. I don't just have an x on the bottom.
you can only do it when you have just an X.
Yeah. So if you only had one vertical
Okay, wait,
asymptote.
so I have a question. How is the line that's tracing the asymptotes on the left side? It crosses the...
It does because that's the one that we found. Like, since we already found it, yeah. So if I were to FOIL these out, I would get, so I've got x squared minus 4, FOIL that out, x cubed minus 4x on top, and what would the bottom be? Minus 2x minus 3. So I just FOILed it out because that's what I need for long division. So I've got x squared minus 2x minus 3. And then on the inside is my numerator, which would be x cubed plus 0x squared minus 4x plus 0. And I'm going to give us, going to give us a little bit of space here. Okay, so from here, how do I get from x squared to x cubed? Just x. When I multiply that, x cubed minus 2x squared minus 3x. And then I flip every sign. Cancels. 2x squared minus x. How do I get from x squared to 2x squared?
2.
Is that the same as my slant asymptote?
Yeah.
Good. I'm done. I don't need to check anymore.
Wait.
Wasn't that bad?
Oh,